Hello, everyone. My name is Seamus McGovern from the ODSC team. Delighted to be introducing the Red Hat Office Hours today, and we're going to be joined by David, Audrey, and Corey. But just a few quick words before we start this. Just want to remind you that ODSC West is coming up. We're heading to the heart of Silicon Valley. We're going to be in Burlingame, California on October 29th to 31st. So as usual, we have tons of hands-on workshops, training sessions. We have speakers from OpenAI, Anthropic, Google, DeepMind, Meta, all the usual suspects. So hope to see you there. And in addition to that, we've got a ton of events coming up. One event I'm going to be hosting myself on October 10th in San Francisco is what we call Make the Jump Dinner. If you're interested in doing a startup or you have a startup idea, let us know. Head to the ODSC website. You can apply for that. We also have a meetup with Google on October 14th in San Francisco. We have a few webinars coming up. And of course, you can see ODSC West is there as well. So if you can't make it in person, perhaps you can join us virtually. And with that, I would like to introduce the office hours today. We have three great members, three super knowledgeable members from the Red Hat team joining us. We have David White, who's a principal specialist solution architect at Red Hat. We have Audrey Rednick, who's an AI platform specialist solution architect at Red Hat. And then we also have Corey, who is again, another solutions architect, but this time in AI and machine learning and data science at Red Hat. So you are in very good company and, least to be said, very good hands for this office hour. So with that, I will hand it over to the specialists.
All right, I'll lead off here. I'll also introduce David because David did a workshop yesterday and there may be some questions around that. So I want to give an opportunity to answer any questions there. We've got a few slides today. If we cannot, oh, there we go. Looks like we've got some of the chat. I'll confirm with other members of my team. Are you able to get to the comments?
Yeah.
Okay.
Yeah, we can.
For some reason, I can't see the comments, so I'll let you guys field those.
We'll shout out.
Excellent. Okay, perfect. So yesterday we did a workshop. David led the workshop. Do you want to just do a quick review of what happened in that yesterday, David? And
Sure. So once again, thanks everyone for having us. It's a pleasure to show you guys some of the stuff we've been working on and things we're excited about. So yesterday I presented a workshop where I'll post the link. It's a public GitHub repo we have where I kind of, based on what our customers have been wanting and needing, I created a kind of end-to-end demo demonstrating how to do an AI ML project on OpenShift using OpenShift as a platform. It was a very simple computer vision example using the YOLO V8 model. And the great thing I was trying to demonstrate was that, yes, you can do these on your own with your workstation or your laptop, a bunch of open source tools and, kind of jamming everything together yourself. But it's something that's that's not very flexible, right? It's very rigid and it's very difficult to reproduce the results because you've got things like finding the right CUDA drivers, right? You got to find the right software. You got to find the right open source project that's not full of holes and badly need to be patched. So what OpenShift does is it gives you this great foundation where you can plug in pretty much whatever you need to plug in. So this workshop goes through using OpenShift as a platform to do the annotation for your models, for your image, for assets for your models, to do a pipeline to create the training, to do some deployments and testing, all in the realm of OpenShift, which makes it much more stable, much more repeatable, and much more self-service as far as the data science professionals go. So that's kind of it in a nutshell, and we can go into detail, but I think it went off pretty well yesterday.
Thanks, David. And I realized I forgot to lead off with some introductions. So David, if you want to just finish off with your introduction of sort of your background and where you work today.
Sure. So I've been at Red Hat about 4 years. I joined the AI specialist team, or the go-to-market team, where we try to help customers understand what our product offerings are and how we can assist them with their advanced usage for AI projects. Before that, I had a consulting company with a friend, and we lived in that space where companies don't have the expertise, but they know they want those features and capabilities. So my friend, who's a PhD in applied mathematics, he would come up with all the great data science, concepts and core services. I would kind of bring those into the real world and something that's repeatable, using, back in that day, it was like shell scripts and all kinds of ungodly automation to make it work. But that need was definitely there. And in that time, I've seen that OpenShift and Kubernetes, to a degree, that's the only foundational things that you could put in place where you could service all those things and have a much more repeatable, something that you could put into production. So that's my spiel.
Thanks, David. And then Audrey, do you want to tell us a little bit about where you've been and where you're at today?
Sure. So I've been at Red Hat for approximately 4 years. I've only been on the same team as Corey and David for, 6 months or so. Before that, I was in what we call the business unit, where they developed the OpenShift AI product. That's kind of our platform dashboard that sits on OpenShift, which is Kubernetes, essentially. My job then was, as a data scientist, to come up with various workshops, demos, so that we could show people how to perform data science on OpenShift AI and OpenShift. Before that, I worked in the .com industry. I also worked in the energy industry, basically as a full stack developer. However, since I would say 2016, I did more data science as I was moved into a research center within ExxonMobil, where with the computational scientists, I was actually helping them determine how they could get their ideas, their models, their algorithms into production, because they didn't have a sense of what is ML ops. And actually at that time, that term wasn't even coined at that time. So trying to use my background to show data scientists how to deliver their ideas successfully into production. And here I sit now.
Yeah, definitely a practical application to that data science, I think, is what you've really seen, it sounds like. Thanks, Audrey. So I'm Corey Lachkowski. I've actually worked with Audrey a few times, so I know her well. We've had a lot of fun trying to bring a practical use to data science. And my background, believe it or not, I actually was in accounting at one point. That seemed not as challenging as I needed. So I've had a few major stops over the years. I worked in high performance computing for a while, cybersecurity, and then now specifically working with Kubernetes and OpenShift to help operationalize those workloads on a platform. And worked with Audrey in the past, actually embedded into a business unit and trying to bridge the business use cases with data science, with IT. So we have a lot of experience we have a lot of experience between the three of us in this call. And so today, if we're planning to answer any questions that come in through the comments, but if we also have fallback to talk a little bit about our favorite white papers and topics around this subject, just to give you an idea of where our experience has taken us. With that being said, let me see, is there anything we need to catch up in the chat?
Yeah, there's no direct questions. Sarah R. just asked what the live is about. So this live seminar or doctor's hours is for the benefit of not only the people who joined our workshop yesterday, but those who are interested in building applications, I would say AI applications for production, or how to go about developing them. So if you have questions on developing AI products, just let us know how to work with models, that sort of thing.
Thanks, Audrey. Speaking about going to production, I think that's probably the biggest topic, or like discussion point that I think we all hear in the conversations we're having with data scientists. Like how the conversation is usually around, how are you getting to production? How are you going from this experimental state or development state into a production use case? And there's a lot of challenges there, especially when you're contrasting from a traditional development life cycle. There's actually more life cycles that are included in that process. Audrey, I know your background, you were a developer, like you said, in the .com era. So would you like to just maybe talk a little bit about those cycles that are a little different than traditional development, but also how they integrate in data science?
Yeah, for sure. I mean, when you talk about developing any product, say even right now, just a regular application, you typically will use something such as agile development, where you are meeting on a regular cadence and agilely creating features for the product that you're developing. So maybe once a week you'll meet and see which features may need to be refined due to bugs a bit, or which new features you're adding. And while you're adding that, you're always worrying about your, development environment. So you'll have a development environment where you're putting everything in, but at some time you're going to have to push that development environment all the way to production to release your product. You don't want to do that manually. A long time ago, people tried to do that manually, and it was just very messy. It wasn't reproducible or repeatable. So a lot of people started looking at GitOps as a way to do this. So you look at the idea of having pipelines come about where you can use various scripts such as YAML, which we use, to basically write scripts that pull your development or your production code out of a GitHub repository and push it to your cluster, which would have your servers, say, for your application, whatnot, into production, so that people just see the good code. And the nice thing about this is when you find something that's wrong, it's very easy to go in and fix that bug. That bug is saved in GitHub, and then you can use pipelines again to automatically push that to production. Well, that's very well and good for when you're working with just regular applications. But when you start bringing AI into the mix, that's a whole new field. What you're doing in that sense is you're also bringing models in, and you're also bringing more data in. The data especially may have to be curated specifically. So now you're entering an era where we're talking about data science pipelines or data pipelines to get that data to the model. Again, you don't want to do that manually. And there's also training the model with that data. So again, there is a way that you can set up pipelines to do that. And then with your models, we're now in an era where we're talking about model registries. Where can we save these models so that we know the versions, we know the data that was used to train them? And this is something that Red Hat is looking at, is creating a model registry. We have one that will be going live here in the next month or so. It still needs work.
And
but
that's
in
part
any
of
case,
Kubeflow, right? Like that's part of the
yeah.
Kubeflow project.
Yeah, and that is part of the Kubeflow project, which I don't know if Corey touched on this, but with Red Hat, we are a large open source company. We believe in open source. So all the tools that we develop usually have their background in open source, and Kubeflow is one of the things that basically we have our roots in for OpenShift AI. So the pipelines that you see, how we're developing the model registry, has their roots in that community effort where a lot of people can contribute to the open source community. They can take that code back and use it however they want. But I'm getting off topic here. So yeah, now you have the models that you have to have some way to track them as well too. And if something goes wrong with that model, how do you know? So you have to have monitoring for the models, right? So that you can see if there's model drift. So all of a sudden, this workflow that was the CI/CD development process, along with Agile, became, I won't say insufficient, but we needed to add more things to it. So now you're seeing this era of ML ops where you're taking a good look at these pipelines to train models, to get your data in, as well as to push your data from, I would say, like a GitHub repository to production. And I think this is a good place now to talk about how model code is one component of a larger system, because I'm just going to say, and maybe Corey or David can talk to this diagram. We're at the point now with data science. Some people kind of jumped into data science and they said, okay, we're going to do some data science. We're going to build an AI model, but they forgot about all of this CI/CD work, and they forgot about the platform that sort of needs. So I'll hand it over to either Corey or David to go through this diagram, and you can see, or you'll learn about how model code just isn't it. There's a whole realm around it.
Yeah, thanks, Audrey. I'll jump in just for a minute, and then David, you can take this conversation a little further. So just to review, anybody that's been joining live, essentially we've been talking about the various life cycles that are part of machine learning and AI. It's not just as simple as an application life cycle. There's also a data life cycle that Audrey talked about, and then there's also the model life cycle, and components that are part of those that are critical to maintaining that machine model. And then also, I think a big emphasis here that we've heard is also around automation. So whatever we're doing, we want to make sure that it's reproducible. That's science, right? We want to reproduce those results. And some of the tools that we'll be talking about today center on Kubernetes, which is focused on that a declarative way of providing services and application states. And so that's part of this sort of landscape here that we're talking about, the models inside this landscape. And there's a lot of other things we need to do in order to support that model or application. So also one other thing I wanted to say, I'm monitoring the comments. I see Eric, he's talking about how he went to production. And one thing that's key there that definitely we see as a pattern and we believe in as Red Hat is using containers around application deployment. So all the automation that happens through a container platform, specifically Kubernetes, helps us get to a solution in an automated way. With that, David, go ahead and feel free to tell us a little bit more.
Yeah, thanks. So this is one of my favorite slides. This has come up from a white paper called Hidden Technical Debt in Machine Learning Systems. It's we have a link in the deck we'll share with you, but the main thing is it kind of visualizes where, we'll share with the white papers. There's a bunch of good stuff in there. The main point of this is this isn't proportional. It's more like, kind of an overview, right? So that very small box, that represents all the work that's done around the model itself. And everything else, which kind of dwarfs it by comparison, is everything else required, right? And if these were to scale, I think that anything around data would be bigger than the entire diagram, combined. Because, as you know, like data is the most intensive part that you have to have because, it's kind of the inverse of the DevOps model, which is the functionality application is the main point. So you're always trying to improve the functionality and add features, whereas the data is the most important part of any data science effort, any kind of machine learning. So you have to have good data because everything else depends on that. So all of these things are designed around curating, maintaining, and promoting versioning data that you'll be using for training, for actual system operation and those kinds of things, and all the other components that are around that, like configuration management is a big one, right? Monitoring, as Audrey said, is a big one. Managing the processes, doing any kinds of feature extract, all these things that you're used to doing with these projects, you need processes around those to automate them. So one of the approaches is to have a pipeline that can accommodate all these things and bake that into your process. So I see Eric mentioned that. I think he uses Jenkins for continuous automation or continuous integration. Certainly that's one tool that's available. With our products, you can plug Jenkins in, or you can use, as in my demo, I use Tecton pipelines. And we have, as Audrey mentioned, ML Flow baked into our AI offering in that space as well. But these are all crucially important because you're going to want to be able to automate all these tasks so that they can be repeatable, and then you can change your weighting and all those kinds of things. They're all configurable on those kinds of things. So basically just wanted to mention that you need to bring all these things together under one platform, right? And that's what OpenShift with Kubernetes, that's what it actually makes it possible. So if you could think of it as plumbing, right? So OpenShift is kind of the plumbing where you put all your different connectivity and features on, and then we give you a place to string all those together so that you can have a unified environment to perform all these things. I hope I made that. Hopefully that's clear, because there's all kinds of tools that are compatible with our platform. And in the demo, I show that I use a ton of open source tools like Label Studio and MinIO and Python Fast API. But you could easily plug in some of our partners' tools that would plug in just as well to get those same kinds of functions that you want. So anyway, that's kind of a nutshell of generally why OpenShift I think is a great platform for this, because back in the days we used to do this all by hand with tons of machines. Some of them would be just laying around under your desk, and it's like, I got a spare machine and I want to figure out how to work this, and I'm going to be doing all these experiments. So you'd have to string all that together yourself, figure out how to make everything compatible. OpenShift kind of gives you all that integration for free. You still have to do the work to get the data out, but it's a great platform for combining all these things.
And I'll add a little bit more to that, just because I don't want anyone to feel like, oh man, I got to go get OpenShift now to do this. Like, you don't. A lot of that's where we operate, and just to help anyone who doesn't have context around what OpenShift is. OpenShift is an enterprise Kubernetes solution. So the reason we know about it is because a lot of businesses, a lot of large enterprises want a Kubernetes presence, and so OpenShift is that solution that Red Hat's provided. If you don't operate in an enterprise and you're just starting out on your own or working independently or in a smaller system, a lot of people just use Kubernetes to get started. I know one person in the chat was talking about containers, just running Docker or Podman locally, and that's a great place to start. I think a lot of people sometimes start in like a Docker desktop, or what Red Hat's developed is Podman Desktop. Same thing, similar approach to starting with a container, working locally. And then a lot of these tools that have been mentioned operate on a Kubernetes platform. Tecton is a native pipeline solution. Jenkins has been around forever. So many of you may have had some exposure to Jenkins. There's different feelings and some campiness around each tool always. But hopefully that helps to explain why we're talking about OpenShift. That's where we operate, but it doesn't necessarily, you can start smaller. You can start with just containers. You can work up from there to a more complex system. You can use Kubernetes or even Minikube, which is sort of a local tool that you can use to create a Kubernetes instance. with that being said, any other tools that you guys can think of that have been helpful, maybe going from a local development to a larger scale?
While they're thinking of that, there was one question from, let me see who it was, Vinod, and he wanted to know how NLP is used in legal judgment. This is a little bit of ways from what we're doing here, but to answer that, most likely you wouldn't use natural language processing as it is. You would probably want to use a large language model. And I know that the legal industry has had some interesting occasions with large language models where they have asked the large language model that has been trained, maybe not on an extensive legal system, some questions, and gotten back a response that seems to be very good, and used it and found out that that response was incorrect. So what they were seeing from that large language model was what we call hallucination, where it appears that there's going to be a good answer, and the large language model goes on with what it's learned. But in this case, it extrapolates a bit, and the answer is incorrect. There are a couple ways that you can get around this. The first one is if you have extensive compute resources to totally retrain the large language model. Well, we're not all Google, we're not all Microsoft, we don't have all of those resources. Another option, which some people, actually quite a few people do, and we see this with our customers, is they take some sort of foundational model, large language model. Sometimes they'll use something from Hugging Face, and they'll use retrieval augmented generation to kind of make the model have more knowledge to draw from its answers. And what that means is it pretty much optimizes the output of the large language model. So it references, in this case, a vector database, which is usually kind of an authority knowledge base on a particular topic outside of the training data resources. And from that, it's able to create a much better answer, depending again on the information that you have in the vector database. Did you add enough information in there to the legal topic that you're trying to get information about?
I think it's really important to understand some context around large language models. I think most people don't understand sort of their origins. And from my best understanding, we've taken the whole of the internet, like all of this public information, and trained it into a large language model, something that can talk to us about that data, the internet. There's a lot of private data that's not included in that set. And so that model will know nothing about it. It may be able to talk to us in English or other languages, but it can't talk to us about, say, a subject like math, or maybe about cooking. Like, I don't know, there's enough cooking out there maybe on the internet, but more technical subjects that are specific, maybe more challenging for a generalized large language model to provide information for.
Yeah, and if I could just add an anecdote. So about 5 years ago, so before the transformer model and all these things, I actually did a project with my friend I mentioned earlier with using natural language for a world economics project, right? So we essentially, this is before the days of those. So we took the last 20 years of world of IMF data for their country reports, and we sat with an expert and we trained that to recognize recommendations from the last 20 years for 120 countries. And we used that to classify what type of recommendation it was, if it was a financial or a social change and those kinds of things. We were able to put together a report that says, are they biased in their recommendations for a country depending on the stratum that it's in? And it was a very interesting exercise, but this happened way before the transformer model. So the advantage was we were able to get very strict and very specific recommendations after having to work with some experts on how to do that. But now with the advent of generative AI and large language models specifically, it's kind of tempting to shortcut that whole process. Like Corey mentioned, it's kind of sucked up the whole web and brought everything in. But the thing is, you might get advanced advice like, how do you keep cheese from slipping off a pizza? You just add glue to it, right? So these are the dangers of these kinds of systems. And I don't know, we've probably got some people who are experts in transformers, but to me, the biggest thing about that model is, which is a good, and it's a double-edged sword, is like it has to complete the pattern that it recognizes for the question that you've asked it. So if it doesn't know, it'll just make it up. And that's the part where you kind of put RAG in to say, okay, if you need information to pull from, here's something else. So hopefully I didn't butcher that explanation too bad.
That was a really good explanation.
Yeah,
We have another question from Shekirdine. He says, as a newbie, I've been through all machine learning end-to-end applications, but come to deployment, I can't imagine how it is in practice. Is there a particular way to deploy machine learning applications into production, or it varies from industry? So anybody here want to take a crack on it?
I'll give a first shot at that one. So is it different from industry to industry? I don't think the industry is as much of an impact on how that process is. What I've seen is it's very much organizationally dependent. So how an enterprise or company or organization is structured has a large effect on how applications or models get deployed in production. Specifically, go ahead, Audrey.
Corey, there's slide number 3. I added a new slide, and that's the life cycle for operationalizing models.
Oops.
And that takes into account not only your model, but your application as well. Go down. Did I put it in the right area?
You might need to restart the slide deck when slides go.
Give me a second here. Oh yeah, you guys put a bunch of good slides in here. All right. Yeah, let me restart it. Let's see. Is it this one?
That's the one. Yeah,
okay.
That's the one. So I can talk a little bit about this. So I think you can recognize the workflow that we talked about at the bottom. That was mainly for application development, where you have your code, you have stuff that goes to QA, then you have it to deploy, and then you operate and you monitor it, and you kind of keep iterating through that. And as we mentioned, that's kind of like the DevOps type of scenario. When you go into ML ops or machine learning operations, you can take a look at the top and notice that it is fairly similar. We can see that the difference is that there's a little bit more complexity in the ML ops workflow, because you have to consider the data and you have to consider the models. But you're still doing kind of the same thing. You're in terms of, you probably have data that you don't show in the DevOps portion before, but here you have gathering and preparing data. You probably have some sort of data science pipeline that's going to push that data to the model that you're developing. And when you're developing the model, you probably have another pipeline that's going to push it to when you do a deployment. And of course, once you've deployed the model, there's another pipeline where you can start monitoring the model. And then if you get any drift or anything like that, then just like the below where you're reiterating, you could either retrain the model, or you can go all the way back and get more data to really change the weights of the model and how it's trained. So yeah, it's in practice, it's very similar to DevOps. A little bit more intense because of the data and the models, but the key is that you have to have a platform where you can really collaborate with everybody, because of course, when you're pulling in data, you're working with the data engineers. When you're developing the model, you're working with the data scientists. When you're deploying the model, you're working with IT operations, or you're working with an ML ops engineer. So to have a platform where you can easily collaborate, I think, is one of the keys into either getting your applications or an intelligent application deployed successfully.
One other thing here, that there's a couple of patterns also with that deployment that you're talking about, and two patterns that are very common. One, I think, should be considered probably the best practice, at least in my opinion. One is taking models and promoting them from a development environment to a production environment or through a life cycle. A lot of people do that, where they take the artifacts, so those binaries, those blobs, and they promote that into a production environment. The danger of that is your data may be different in a development environment versus production. And so it is best practice to actually promote your automation or promote those pipelines into production, so that you have the same process that's deploying that application instead of moving the artifacts from one environment to another. You can see some of the challenges or dangers in doing that. So that's another thing that I think is key in understanding how do you go to production, or how should an organization go to production. I see we've got one other question.
Yeah, from Vinod, and that's how does the integration of machine learning in a web application happen? That was actually the workshop that I did yesterday afternoon for somebody else. But in
Audrey, you muted yourself.
Sorry, in that scenario, what you have is some sort of model that's going to take parameters. So you may have some sort of parameters that the user would pass in. So that basically makes it worthy of being accessed through a function or an API in a front-end application. So whatever you develop your front-end application in, whether it's Fast API or Dask, what have you, you're going to have an endpoint to the model. So the user is going to interact through the front part of your web application and enter that information or choose it from a drop-down box. And that call, API call, is going to then be made to the model. The model is going to do some inferencing, and then you will get a result back to the user. Sounds a lot easier than it is. There are a number of things that you have to do for that, but that's essentially how you're going to interact web-wise between a model and your user.
So would you say it's more or less like the typical microservices model with web?
Yes, it's very similar to a microservices model. So again, you're probably going to have some sort of microservices in place. I don't know if we have a good diagram on that. I don't remember us ever putting one together. This might be a good opportunity for us to do that.
Yeah.
All good questions about getting to production or operationalizing. I think also a lot of there's something to be said about your approach to machine learning, because there's different, even higher level architectures to consider. Like, and I think we alluded to that a little bit in the previous conversations. But like, do I have one model that sort of does a lot of things, or do I have more specialized models that all work together in tandem in a symphony of models to provide support for an application? Like, for example, you may have a web front end. You may LLMs are a big thing right now, and then that associates usually with some kind of chat bot. I want the computer to talk to me about stuff. And we may have more specialized models on the back end of that application that are going and doing specific functions, answering specific questions about something specialized versus general. So there's different approaches to how we have these models work together as an application, and also how they're consumed as well. I think, David, with the workshop, you had a few things. I think you had it pretty tightly integrated between the API and the model itself, but you can decouple that a little bit too.
Yeah. Yeah. So the YOLO model itself has a lot of different parameters that you can use for inferencing and training and those kinds of things. And I basically took those and made endpoints for each of those so that any web application or anything communicating through the API could call those functions. So for example, I could get it to infer an image and then give me back the detected objects, also to bring back the actual bounding boxes and those kinds of things. And that was a pretty easy integration. And another one, which it'll get its own workshop hopefully one day, is the traffic camera management. So for one of our Department of Transportation customers, we have inferencing from their traffic cameras. And I was able to integrate that model into a basic front end dashboard where it just calls. And I see Vinod has asked a follow-up question about what types of APIs. And I'm just using straight REST calls, right? So it's sending back some JSON data based on, and I think for the most part, these are things configurable by yourself. So for me, I can figure it out. Okay, this is the one that'll tell it to start inferencing. This is the one that gives the an analysis of the density per hour or per minute, and this is the one that tells me I can change cameras. So you can define whatever endpoints you want. And I think for good practice, you would want to have monitoring ones and observability as well, because you'll want to track how well your model is doing so that you could feed that information back into your pipeline to make adjustments and improvements. But yeah, the APIs are just, however you want to do it. I chose REST because I think that's a pretty simple one.
And Corey, if you could refresh the slide deck again.
Yes.
We won't talk too much about the slide that I'm going to bring up, but it gives you a good idea, and it'll be slide 7, the last slide. I know that a lot of people are interested in how do you put all of these things together for, say, a web application. This is a simplistic diagram. The main square around where you see Kafka, and then you see some machine learning models and the back end, front end of an API. That's just our OpenShift AI platform. So just think of that as an operating system, if you will, but being able to do a lot more things. So we're going to have our models. These models can be worked on by the data scientists. The models are going to be pulled in this case, from a GitHub repository where the changes are being made. This is for edge devices, so you're getting data that's streaming from the edge. It's time series data. Some of this data you may want to save in a database. You see the database in the far up right corner so that you can retrain the model in the future. But the main thing is you see the person or the figure in the bottom right-hand part of the corner where they are accessing the front end of your application or web application. So what David was talking about APIs, there's probably going to be some REST calls in there where you click an option to look at something, and then you're going to have some microservices in the background with your background anomaly application. And that's going to go and connect to your models for more inferencing information and then getting the information back. Again, a very simplistic kind of overview of maybe what you would do for a device at the edge that is trying to detect some sort of failure. Again, I think what we're hearing from a lot of people is probably the request for a workshop that can kind of show you how to take models and the web apps, and maybe the Parasol workshop that we have may be of interest to people in the future. And that, by the way, is where you take a large language model, an object detection model, and you basically go through and curate a number of insurance claims by people that have had accidents. And the large language model will pull out the date, the time, the user, the location of the accident, and then our object detection model determines the photograph that's attached to the report, whether or not that is an actual moderate or severe accident. And then we have a number of pipelines that would process a number of these requests to a web app where you can click on and look at each claim. So that might be something that we can do in the future here with ODSC.
Yeah, one thing that I remembered also talking about model inferencing, or this API, this endpoint. There's two major ways of doing that. RESTful APIs has been around for a while. That's one way to get that inferencing information from the model. Another very common, more modern way of doing it is gRPC, which is just a more efficient way of having that communication between your inferencing and your application. So it's there's a little less protocol overhead if we're getting technical in the way it communicates. So you'll see that as an option for a lot of inferencing from a model.
You guys have really asked a lot of fantastic questions, and Eric, you're going gangbusters on your comments. Way to go.
So yeah, the question that we're seeing now is, what's the difference between ETL and ELT, and why is it so important? He goes to answer it, of course, like, what's more important? Saying ELT, extracting, is easy. It's 2 lines of code, and then transforming is hard. I think that's one thing. Actually, that reminds me of a very important topic around this subject. So no matter what, it's the same story that's been around for a long time in IT, is garbage in, garbage out. Like, if we don't, one of the most important things to do is get our data to a state that's usable and very good. And data engineering is actually one of those gaps that we often see in enterprises, and also in many other places, that these companies have not been able to action any of the data they have. They may have large amounts of data, but they haven't been doing business decisions or actioning that data for a long period of time. And so to jump right into machine learning and AI, there's a lot of technical debt. There's a lot of hills to climb before they can use that data. And from like, I don't know, Audrey or David, from your experience, like, where's the place to start? Like, when you find a situation where you're not able to action that data, like, where do we start?
That's a hard one. You start at the very beginning, and you start looking at your data. And I think what a lot of people don't appreciate is there's so much that goes into understanding your data and curating it. But what I mean curating, it's all the way from cleaning to doing labeling for, say, object detection. And it's a big job. It's a really big job. And it really takes somebody that knows a lot about that particular process that you're trying to do in AI to be able to get the right data to train the model, or the right data that we need to see how the model would break down, so that you could also be aware of what data is not going to work.
Right. It's an interesting paradigm shift, because I'm kind of came from the olden days where structured was more important than unstructured data, or was more prevalent, and that was the common that was the baseline, right? Now it's the exact opposite. It's, you get much more value out of unstructured data, because it's, it can span a lot more. The problem is, how do you link what you have with what you need, right? How do you know if you have enough information to even do these analyses? And since then, since data, big data was first a term, tons of more tools and processes and methodologies have come into place to make it a lot more palatable to go from an unstructured standpoint to get the data that you need to support it. So these are all really important questions, and there's no easy answers, and there's no one-shot tool that's going to fix it all, which is why you need a platform that's capable of bringing the best of breed for that for that task at hand. I did used to actually work for Oracle, so I know about big databases, but since that time, I've seen in the field with the customers that there's a lot more to data than just columns and rows, right? I mean, you see that in practice when it's like, I have this question, how do I answer this question? And here's the data I have at hand, and it's like, okay, now I need to enhance that data. Is that something I can find, or something I can create? So these are all important questions that you're going to have to answer when you start these projects. And it's better to spend your time thinking about that than how I'm going to put all these puzzle pieces together on a laptop that's only got 16 gigs of RAM. So,
and sometimes there's some debate around those definitions of like what's structured data, because like from my experience, a lot of data is trapped in Excel spreadsheets everywhere or CSV files, and like I mean it's structured, sort of. So maybe not normalized, but I guess there is structure to it. Again, like you find data in various states in an enterprise. Some has been transformed, some has, like, some organizations have a very mature like data lake. Others are more like a data swamp. Like there's a mixture of maturity in that data quality.
Yeah, and if I could take a stab at Vinod's question, I think if I understand it, it's like, are there tools in MySQL to do database analysis? And I would say technically there probably is, but that's a trap you probably wouldn't want to fall into. As I said, I haven't worked at Oracle. I know there's a ton of stuff like PL SQLs, that a language that was developed to do just that kind of thing, to do operations on data in the database itself. But then you get shackled with that solution, and it's not very scalable, and it's very database dependent, and it's very language dependent. So you can't really apply that if if you're looking for data to augment what you have. 9 times out of 10, it's not going to be in the same database or even format or maybe even language that you're looking for. So I would kind of recommend using external tools to do analysis of data.
Just off the top of my head, a few things that I remembered a lot. I think sometimes it's hard to know where to start. If you're even if you've been in the field for a while, it's sort of hard to know where to expand your knowledge. So I'm going to list off a few tools that I find very universally applicable. One is rclone. Rclone is a command line tool that has the ability to transfer data from various like point A to point B type things. It's raw data. Generally, it's not structured data, but it works with S3 compatible storage. It works with SSH or SCP, FTP. Like it supports a lot of different protocols. It's called rclone. So that's just a tool that I find has been very useful. Another one is MyFi. Did I say that right? I think so. Yeah. It's a Java-based application. It's Apache, and it allows to essentially move data from one source to another. It also does some transformation there as well. And that's just been a tool that I've seen, at least where if I can run Java, I can run that, and it's web-based, and I can do a graphical interface of sort of that data flow that I want to happen. So that's sort of another tool that I can think of just off the top of my head that's been very valuable in certain use cases.
Yeah, and people have asked me what tools I use, and it's bad because like I grew up in the .com industry, late 90s. So, I mean, I could be happy just working in Notepad like we did back then. But I would say if you are going to start developing applications, get yourself a really good IDE. Don't jump into the world of Jupyter Notebooks and Jupyter Lab and leave. Jupyter Notebooks shouldn't really be put out into production. You may want to start looking at something like Spider. I use PyCharm IDE. Jupyter Notebooks are really good for trying out ideas, making notes on things that you've tried because you run various blocks of script. But if you're going to get serious about bundling your code, it's better to write proper Python scripts. And that's where you want to get a real good IDE, such as, for me, it's PyCharm. Another one that's popular for people is VS Code.
I love VS Code. It's so extensible. That's like, I've wanted to hate it and I can't. I love VS Code. and also just you can have that extensibility in VS Code. So if you do want to sort of do Jupyter notebooks, or at least start there, it has a plugin that allows you to run those within VS Code and interact with them. So,
and that can run
also good too.
And we can run those on OpenShift as well. The IDE can actually run inside OpenShift, so you get much more memory than you have on your laptop. So.
Yeah, so VS Code can be containerized, and if you containerize it, it's very portable. Like David was saying, like, you know, a lot of these problems are bigger than your local workstation, and so if you can interact with that data like VS Code and be running a container right next to the data on a large Kubernetes platform, there's a lot of advantages to that. Also, a lot of you probably don't have access to, say, a GPU locally, and there's some benefits to that, especially with training. David showed that in the workshop, how GPUs can accelerate those workflows. In fact, David, what was your experience? I know there was a little bit of learning between training using GPUs. Can you talk about that a little bit?
Sure. So the initial model I had was I only had about less than 1,000 elements of images to analyze and train. So initially I started that on my CPUs, and that would take, I don't know, a couple of days, like at least 17, 18 hours to train. So I had an old gaming laptop laying around with an RTX graphics card, like a 3080 or something. And I just loaded that up with Linux and ran it, and the whole thing ran in like 6 minutes. So it's like orders of magnitude improvement. And the great thing about it was I didn't have to worry about putting all those drivers together. I just added it as a node on my network, and our certified operators picked it up and made it available to my workspace. So all I had to do was just write my code, put the library in, and bam, it was off to the races. So it's a huge improvement. And we have another workshop where we show you how to do distributed training. So if you have access to multiple GPUs, or maybe you can spin them up in a cloud, which is a great feature. We have the auto scaling where it'll automatically get the provision the resources, and then to get rid of them once you don't need it, so you don't have to get overcharged. Running that in the cloud, that makes bursting in the cloud an actual desired state now. So yeah, lots of great things you can do once you have a platform like OpenShift to play with.
Mm-hmm. Yeah, thanks, David. That's definitely, like, not all workloads necessarily need that acceleration, but for ones that do use it, very helpful. Time is money in the enterprise. I see one last question. I know we're coming up on time here. One last question was, how does Tesla distribute its onboard camera, or I guess their data? I don't know. I know they published a few papers externally. I know a lot of solutions that deal with IoT have a messaging queue. They use messaging protocols. Actually, I think, David, you actually have a pretty decent experience with that. Do you want to talk about sort of the IoT space and gathering that data?
And while he's talking about that, Corey, refresh your deck and go to slide number 8. That way people have a link to use our 30-day trial of the OpenShift AI platform.
Okay. I think if you're referring to doing local inferencing, is that what you mean? Like to do local inferencing to distribute the collection of compute whatever for centralized processing, or?
Well, so I was thinking, sorry, I probably didn't prompt you very well with that. But I know that you've done some stuff with like cameras, right? You've had sort of this edge use case, right? You got to pull this data in. Like what? I know there's some things that you've learned from that.
Sure. So yeah, so basically you have to decide if you're going to queue those up, which we have some great message-based system, like we have Kafka, and I was using MQT because it's I'm cheap and I wanted to not pay for anything. So I set up a bunch of cameras set up to connected to my Raspberry Pis, and I use MQT as the message broker. And I would just, have it take images every X amount of seconds, or, whatever time, X amount of frames, and then store that in message queues, which then can be picked up by central processing. Now, I've since then added a ATX or AGX Orin to that. And it's a great box for doing inferencing in the field. This all has to do with data gravity, which is the big thing. It's like, how much pre-processing do you need to do to the data, or how much pre-intelligence do you need to do? This is an extremely important consideration when you're architecting the system, because if you're doing everything in the cloud, you're going to suddenly be realizing how expensive it is to transfer data to and fro. If you've got campuses or remote sites that are collecting the data, moving all that data up to the cloud and back, it's very expensive. So you might need to do some processing in the field, which is where these like near edge or edge devices can take off some of the load. And that's all supported under OpenShift as well. Like a container is a container is a container. It should run wherever you can run containers. If I'm running containers at the edge and then I'm processing some of their data in the cloud, then I can get as much value out of that data in every avenue as I can. I hope that answered the question. I think I might have babbled a little bit there.
No, that's exactly what I was thinking about. Yeah, like I think that's a really good like narrative there, and definitely I always enjoy hearing about some of the things that you're learning and the challenges around that, because IoT is a big one. I don't think we talk about it as much right now. Like we're definitely, at least in the media, it's all about LLMs. Like, oh no, the computer can talk to me now. Like, but IoT is the big deal. Like that's still a big deal because we have so many data sources now that we have to bring together, and those data sources can be very valuable to training a machine model. So, and I know, David, like most of your stuff lately, I think has been around computer vision, which is just a small like subset of machine learning, but very interesting, very applicable to like manufacturing.
Yeah.
And things like that.
And if you're interested in more in kind of looking at how you would structure or work with data that goes into an LLM model to eventually produce a chatbot, you can join us for the next live training, which is next month, where myself and another one of my colleagues will show you how to structure healthcare data and add it to a Weaviate vector database, and then go on to see how that data can be used in the healthcare industry for future applications. But I think we're probably at time. We're like 1:02, so I'd have to like thank everybody who joined us for this session to ask us questions. It's been really fantastic to have you just ask us questions from all across the board. It gives us a really good idea of what's important to you. Plus, for us, it's a lot of fun to ask these questions. It's like having an exam or something like that. It's cool. It's a lot of fun.
Thank you everyone for joining. Actually, thank you David, Audrey, and Corey for this interesting session. Our first office hours at ODSC, it was really fun. And thank everyone for asking questions. And as Audrey mentioned, we will have a session next month, another training with Audrey. So if you want to join, please feel free. And yep, I read one more comment. And yeah, thank you everyone again, and hope you will have a nice day. Thank you.
Thanks.